Welcome back everyone, Patrick here, moving on to the next example, still dealing with factoring. So we have to explain why each of these here is neither a difference of squares or a perfect square trinomial. And to explain this, what I'm going to be doing is using the formulas that we went through in previous videos for a difference of squares and a perfect square trinomial. So starting with part A, notice that we got 16x minus 25y squared. So the first thing to actually check is whether you're dealing with a potential or whether the expression you're given is close to a difference of squares or a perfect square trinomial. And over here we could tell that this, even though it's not a difference of squares, it's close to being a difference of squares. So the first thing is noticing which of the two you're dealing with. And then once you know that, you can then compare it to the formula. So because we're dealing with a difference of squares in part A, let me write that formula right there. And why is this not a difference of squares? And basically what it is that this 16x over here, we can't write in an a squared format. Because remember, a difference of squares, what you want to do is rewrite the ends to be in this format. So for example, if you got like, let's say 9x squared minus 16, right? This over here, we can rewrite as 3x squared minus 4 squared. And then it's in that a squared minus b squared format where the a value is 3x, the b value is 4. Problem is this 16x, we can't rewrite like this. This 25y squared, we can. So I could take the 25y squared and rewrite as 5y squared. But notice that this 16x, there's nothing that I could put in brackets and square it in order to get that. You could take the square root of 16, so you could put a 4 here, but you can't take the square root of x, right? Because if I put an x over here and square this, well, that's the same as 4 squared x squared, which would give us 16x squared. So if this was 16x squared, then you can write it like that, right? But because it's 16x only, we can't take this expression and put it in that a squared format. Hence, it's not a difference of squares. Okay, so that's the explanation for part A. Part B, notice that we're definitely not potentially dealing with a difference of squares here, so this would maybe be a perfect square trinomial. And remember, what's the formula for a perfect square trinomial? It's a squared, this could be plus or minus, then we got 2ab plus b squared, and then that is going to factor into a plus or minus b, and that's going to be squared, right? So if this is positive, this is positive, this is negative, this is negative. So again, what we want to do is compare all of these to the formulas we're given. So if we take 9x squared plus 10x plus 4, I'm basically going to use the same process that we used when we factored it, try to take this, rewrite in this format. And what are the first steps? Well, usually I work with the ends. So this 9x squared, I'm going to rewrite as 3x squared. And then this plus 4, I'm going to write as plus 2 squared. So with the ends over here, notice that the a value has to be 3x, and then the b value is 2, right? Taking this, you know what, we could even erase this here just so you're not getting confused, right? Taking this, I took the ends, rewrote it, so I can get the a and then the b, and then we have a positive here, so notice we'll have plus 2ab, so 2 times the a value, which is 3x, times the b value, which is 2. And what's the problem here? Well, 2 times 3x times 2 would give us 12x, and 12x is not 10x. Right, so because that middle term here, using the perfect square trinomial formula, is not equal to this middle term, then it's not a perfect square trinomial, right? So we could say this 10x here does not equal the 2ab portion of the formula. If it was 9x squared plus 12x plus 4, then it would be a perfect square trinomial, or minus 12x, right? Because it could be plus or minus here, so this could be minus 12x as well. But because it's 10x over here, and then we have the 9x squared and the 4, giving us an a value of 3x and then a b value of 2, that middle term is not equaling 12x like it should. For it to be a perfect square trinomial, it's 10x instead. So it's because of that middle term there that this is not a perfect square trinomial. And you could explain it like this with this formula. You could say that that middle term is not equal to 2ab. Moving on to part C. Again, here with part C, are we dealing with a difference of squares or a perfect square trinomial? Well, if anything, it's going to be a perfect square trinomial. We could tell that it's definitely not in this kind of format or close to being in that format. So it's definitely not going to be a difference of squares. So let's rewrite this. And notice that what's the problem here? Well, this term we can't write as a squared, right? Because we can't take the square root of 15. This 64y squared we can rewrite as 8y squared, so we could tell the b value should be 8y. But this over here, this 15x squared, there's no way to take that, put something in brackets, and then square it. Okay, so we can't even get an a value from there. Now, if this was like 16x squared, then we could put 4x squared. And then the a value would be 4x. The b value would be 8y. But then, give me a sec, but then the middle term wouldn't satisfy that, right? Because we'd have to have 2 times the a value, which is 4x, times the b value, which is 8y. And that would give us 64xy. Sorry, give me a sec here. Yes. Right, it would have to be 64xy in the middle if this was 16x squared. So even if this was 16x squared, it still wouldn't work out. It would have to be 16x squared plus 64xy plus 64y squared in order for it to be a perfect square trinomial. But we didn't even get to that part. The fact that we can't take this 15x squared and put it in that a squared format lets us know that we're not dealing with a perfect square trinomial. These n terms on a perfect square trinomial and for a difference of squares, actually, they always have to be able to be rootable, meaning they always have to be able to be rewritten in this kind of format, being able to put something in the brackets. And the 15x squared, we can't do that. Now, what about part D? Notice here, x squared plus 49y squared. So kind of close to a difference of squares, but it's not because of this positive. If it was negative, then it would work out because we could then rewrite this as x squared minus 7y squared. So then it would be in this format where the a value would be x, the b value would be 7y, and then this would factor into x minus 7y, x plus 7y. Okay, so it's in this case only the sign. This here is a sum of squares. Okay, a sum of squares you can't factor, right? It's not a difference of squares like what we're looking for. This here, it has to be a negative. Okay, so kind of a unique question, just more like a communication type of question, but something you may run into of explaining why something is neither a difference of squares or a perfect square trinomial. What you want to do is you want to basically use the formulas and see which portion of the expression doesn't fit into the formula.